Hello, everybody. So, I would like to start with a quote. Perfection is achieved not when there is nothing more to add, but nothing more to take away. In DSA and CP terms, space and time optimization. This quote sits at my heart when I solve DSA problems and get stuck due to TLEs. Welcome, everybody, to DSA Carnival 2.0. It will be a 10 days course and will be streamed on our YouTube channel. After the completion of the course, students will be provided with some quizzes to test their understanding. Well, that is not it. We have a lot of prizes in the store for all the participants. Enjoy the 10 days learning journey. I would first like to thank all our sponsors and Geeks for being the title sponsor. Everybody agrees DSA is such a beautiful and fundamental subject for computer science and computer science students and enthusiasts. But a lot of us struggle and don't feel competent while practicing DSA problems. So, what makes it tough? But rather, the question should be what makes it easy and amazing for some? Well, the answer is courses like DSA Carnival 2.0. Today's topic is arrays and some famous algorithms related to arrays. The session will be followed by a quiz. Link for the same can be found in the description. It will be open for 30 minutes after the session. The quiz winner will also be awarded with a prize. Well, to guide us through, let's welcome the speaker of our today's session. It's a great honor for me to introduce our speaker, Mr. Vivek from Programming Pathshala. Programming Pathshala is an enterprise helping students learn to code and be industry ready. Mr. Vivek has an experience of teaching 10,000 plus students for the interview preparation. He is an IIT BHU graduate and has worked at Amazon for 3 years. He has in-depth knowledge of data structures and algorithms. Many of his students now work at companies like Amazon, Microsoft, Paytm, Directly, Razorpay, and many more companies. Thank you so much for joining us. We are excited to have you here. Excited about the amazing session we are going to have today. Over to you, sir.
Hi everyone, am I audible? Can just type in yes or no. Am I audible? Okay, can you guys see the whiteboard? How many of you can see the whiteboard? Can just type yes if you see that. Okay, I think in that case we can start then. Cool. So yeah, hi everyone. I'm Vivek, and I'm one of the co-founders with Programming Pathshala. And prior to this, I've been a software developer at Amazon, and I did my studies in computer science at ITBHU. I did my BTech from there. So yeah, I think the topic for today's class is arrays. So how many of you, I'm not sure if I can do a poll here, but do you guys have a fair idea of what arrays is, irrespective of your language? Do you all know how to declare an array, play around with an array? I assume that you do have that. So given that we have that knowledge, we can learn some techniques on arrays. We can learn some very simple questions and we can work away on that. Okay. Okay, I believe everyone should be able to see the whiteboard now. So let's quickly just start with a simple question. So there are various techniques and various algorithms associated with using arrays. I mean, from something as simple as inserting or deleting in an array, somebody can ask you a question on dynamic programming, which is related to arrays. Okay. So let's pick first variety and we'll try to cover that in detail and then we'll move on. Okay. So let's take a simple question. The question is that we have been given an integer array of size n. Okay. And what I want to do is I want to find the sum of elements from index I to j. So let's say that's your array. It contains some elements like that. Now let's say this is your index I, this is your index j. So you want to find the sum from here to here. So what can be the simplest solution to get it done? The simplest solution can be you can just write a for loop. That for loop can start from index I, go till index j, and you can sum up all the elements that are present in this space, right? Okay. Now let us change this question a bit. Let's say you have been given a quantity q. It denotes the number of queries. So you're going to get so many queries and every query will contain two things. So let's say you have I1, J1, I2, J2, I3, J3, so on. For every query, you have to tell the sum from the given index to ending index. So if let's say I2 is 5 and J2 is 9, then you have to tell me what is the sum of index from 5 to 9, right? Okay, so I would like to listen to some answers. If you have any, you guys can just put up your answers in the comment section. If you have to just find the sum from I to j and the size of array is n, then how much time does it take? What is the time complexity of finding sum from I to j? Anyone who can type the response in the chat box. Yeah. So that is going to be order of n. Why? Because in the worst case, if your I is 0 and j is n minus 1, you will have to traverse from the beginning till the end, finding all the sums. So I can say finding the sum from a certain index to a certain index has a complexity of n, if you are doing it in a brute force manner. Now, if there are q queries, then overall time is going to be q into n. As simple as that. Because each query takes you n time, so q queries are going to take q into n time, right? Okay, can we do better? Because everything is about optimization. I mean, when you face interviews or when you solve challenging computer science problems, it's all about optimization. You can come up with a brute force approach like that very easily, but can we reduce the number of computations, the amount of time taken? Any approach, feel free to suggest, type it in the chat box. I hope I am audible now. Okay. So let's say we have an array like that. Okay. Now, can we create something called as prefix sum? Prefix sum is nothing but cumulative sum. So when I say prefix sum till this point, it means that sum till this point. When I say prefix sum till this point, it means sum till that point. So let's say we create that. The prefix sum till here is just 5. Till here is 6, 10, 9, 11, 11, 17. Right? These are the prefix sums. Now, when we have prefix sums, can we somehow use them to find the sum from a given index to a given index? So let's say I want to know what is the sum from here till here. If I want to know that, can I just subtract from this 11, this particular thing 6? When you subtract 11 and 6, what is it that you get? 5. And now you just check the sum of this thing. 4 minus 1 is 3, 3 plus 2 is 5, 5 plus 1 is 0, which again is 5. So once you have prefix sums computed, then the job is very easy. And this is quite intuitive. So this is not just a coincidence. I can just say that, let's say that's your array. And you know the sum till this point. This is your index j, right? And now you know the sum till this point. Let's say this index is I minus 1. This is I minus 1, that is j. So if you know the sum till this point and sum till this point, and if you subtract that, let's say this much of sum is s and this much of sum is small s. So if you do s minus s, whatever you will get, that will be your answer, because that will denote the sum of the remaining part, which is that. So this is the idea. You know the prefix sums till various point, prefix sum ending at j, prefix sum ending at all the different indices. So if somebody questions you, give me the sum from I to j, what I can do is, I can just do prefix sum till j minus prefix sum till I minus 1. This is a simple idea, given that I have pre-computed the prefix sums. Okay, does this idea make sense? Cool. So now based on this idea, I can answer my queries much faster, because now what I can do is, let's say I have this array, I can create another prefix sum array, and that is going to be super easy, right? So I can just have a variable sum, which is initially 0, and I write a for loop. In every iteration of for loop, I add the current element to s, and then I say that s is the prefix sum till this point. So you can create a separate array wherein you can keep inserting the prefix sums till different points. And after you have done that, then your job is very easy. So how much time does it take? How much time does it take to create prefix sum array? It is just going to take order of n time, because you will have to iterate from beginning till the end in the actual array. And once you have done that, then you can scan all the queries one by one, and for every query you can just return this value and your job will be done. So this is a very simple technique of pre-computation. Why it is called as pre-computation? Because first you pre-compute the prefix sums, and then you answer all the queries rapidly. For every query, now you no longer have to travel from I to j. You can just return the difference, psj minus psi minus 1, right? Okay, so that's the idea. So what will be the overall time complexity of this approach? The overall time complexity will contain two parts. The first part will be pre-computation. So when you are pre-computing this array, you are going to take order n time. And then how much time do you take to answer a particular query? For a particular query, you are able to answer it in order 1 time. So all the q queries will be answered in q into 1, which is q time. So overall time will be order n plus q. Now if you see, for the basic approach, the brute force approach, the time complexity was n into q, and here it is n plus q. So I can say n plus q is much smaller than n into q. Just imagine both are 100, 100. This is going to be 10 power 4, and this is just going to be 200. So the current approach is way better. Why? Because of the idea of pre-computation. And this idea of pre-computation is extremely helpful in so many other scenarios. You know, the way you have created prefix sum, if you have an array for it, then if ps of I is written, ps of I, what does it denote? It basically denotes the sum of elements from index 0 to I. This is what it denotes from beginning till the end. I'll ask you one question. For every query, you are returning this quantity. Can something go wrong? Can something go wrong in this piece of code? Look at this thing, I minus 1. Can it create any issue? The answer is yes. Because what if your I is 0 and j is, let's say, 4? So if your I is 0, you will do ps of 0 minus 1. It will give you index out of bound error, right? So how to take care of that? How to take care of that? If somebody asks you, give me the sum from 0 till 5, I would say, you know, that sum is ps of 5, because ps of 5 is what represents that. So that case needs to be handled differently. So you can write a piece of code which says if index I is 0, we'll just return ps of j, because ps of j returns the sum from 0 to j. Otherwise, we will return this quantity, ps of j minus ps I minus 1. This was one edge case to be taken care of. Okay, another thing, the way we have computed prefix sums, we can also compute suffix sums. So suffix sums means you are computing from the end. So if you compute something called as suffix sum, what is the sum from here to here? It is just 6. From here to here, it will be 6. From here to here, it will be 8. From here to here, it will be 7. So you never know. You never know in what question, what kind of pre-computation is going to be helpful. Is it prefix sum, suffix sum, so on and on. Now, the way we are computing prefix sums and suffix sums, can we also compute prefix max, prefix min, suffix max, suffix min? What is the meaning of prefix max? Let's say I want to know the maximum element from 0 to I. That should be contained in prefix max of I. If I want to know the prefix sum from 0 to j, that maximum element should be contained in prefix max of j. Just think about it. Can we write a piece of code that gets that done? Okay, I hope I should be audible now. So I was just talking about how we can figure out the prefix max. So let's say we have this array, and if we know the maximum from here till here, which is 5, can we use that to know the maximum from here to here? The answer is yes, because the maximum from here to here will either be 5 or it will be the new element. Because your new element, if it is greater than 5, then that will be the max. And if it is smaller for some reason, let's say it is 2, then we can say that whatever was max from here to here, that will be max from here to here. So I'm just going to write an expression, but that expression means exactly same thing that I'm going to say, that I have just said. So if we want to know prefix max from 0 to I, for that, we must first know the prefix max from 0 to I minus 1. Let's say that is known. And now we should look at the current element, which is array I. And whatever is the maximum of these two, that will be my prefix max from 0 to I. So that's the idea. So I can say that prefix max from here to here is this element itself 5. Then we can compute the prefix max from here to here. So we can just write a simple for loop. And with that for loop, you can compute prefix max ending at each index. Similarly, you can compute suffix max also. You can compute the maximum element from the end. If you want me to write the code, it will be very easy. I can say prefix max from 0 to 0 is going to be array of 0 itself, right? Because from here to here, this element itself is maximum. Now, in order to find prefix max ending at index 1, index 2, index 3 till index n minus 1, we have got to write a for loop. So let's say there is a for loop running from index 1 to n minus 1. And now we can just use that formula. We can say prefix max ending at index I is going to be maximum of prefix max that ended at I minus 1, comma, A of I. Right? So this way, by the time this for loop is over, you would know what is the maximum element ending at all the different indices, where the starting index is fixed. The starting index is 0. So these things are called as pre-computation. And using the very simple idea of pre-computation, you can solve very, very, very challenging problems. So we will take a look at one problem. But if you have anything to ask till here, feel free to ask. I'll just go through your questions if you have any. Okay. Great. In that case, we'll just move ahead from here. So we know how we can compute prefix max, maximum ending at each index. Now let us take a look at a question. So this happens to be an interview question asked in a very well-known company. So we have been given an array again of size n. And the question is, we have to check if there are 3 indices I, j, k such that check if there are 3 indices I, j, k such that I is smaller than j and j is smaller than k, and also the element at I, which is array of I, is smaller than element at j and that is smaller than element at k. So you have an array and you have to check if there are 3 indices such that I is the smallest index, j is next greater index, k is next greater index, and the elements at those indices follow this relation. If you're able to find such a triplet of index, you should return true, otherwise you should return false. That's the question. So does it make sense? Yes or no? Do you understand the question? I'll read out the question if you're finding the font a little Just listen carefully, okay? There is an array of size n, and we have to find if there are 3 indices I, j, k inside that array, so that I is smaller than j is smaller than k. And at the same time, the elements at those indices follow this relation, that array of I is smaller than array of j and array of j is smaller than array of k. So tell me, how many of you can solve this question? Forget about optimizing it. Can we try coming up with a basic approach which can solve it? Any thoughts? Okay, how many of you can write 3 nested for loops and then solve this question? Can we do that? Yeah. So the simplest way could be, we can say, let's say we have an array, just to give an example, which contains 5, 4, 9, 6, 2, 10. Can see this array? What should we return for this array? Do you find a triplet in this array which follows the given property? Yes or no? If yes, then what is that triplet? 5, 4, 9, 6, 2, and 10. So here, let's say this is your index I, that is your index j, and that is your index k. Then you can see that index I is smaller than j is smaller than k, and 4 is smaller than 6, which is smaller than 10. Right? So we should be returning true for this case. Is it making sense to everyone why we should return true for this case? Simple enough. If you look at this particular example, somebody said 5, 9, 10, that is also right. 5, 9, 10 is also another triplet. So as most of you have suggested, we can write 3 nested for loops. Okay. While writing the for loops, we will make sure that our j always starts after I and our k always starts after j. So you can just say there is a for loop for index I varying from 0 to n minus 1. And now inside this, for j varying from I plus 1 to n minus 1. And now inside it, you can have yet another for loop, k, which varies from j plus 1 to n minus 1. The important thing is I starts from 0 till n minus 1, j starts from I plus 1, and k starts from j plus 1. Now inside this, you have a triplet AI, AJ, AK, and you can compare. You can compare if AI is smaller than AJ and AJ is smaller than AK, you got your job done. You got a suitable triplet. What will be the time complexity of this approach, given that there are n elements in the array? There are 3 nested for loops. One of you is saying n cube. Okay, others? Do you agree with that? That's perfectly right. Why? If you look at it, the first for loop is going to run for n times. The second for loop, in the worst case, this will also run for n time. And the third for loop, in the worst case, this will also run for n time. So n into n into n, n cube. It will not be exactly n cube, because for certain values of I, j will not start from 0. It will start later. But if you have learned a little bit about order of expressions, you can figure out that it will be very, very close to n cube. But n cube is very bad anyways, right? The time complexity of n cube is bad. So can we somehow optimize it? So one of you have suggested we can use the concept of pre-computation, finding prefix max and whatever. So how many of you feel that using the idea of pre-computation we can come up with an intelligent approach than this? Is it possible? And if you feel it is possible, then you can also mention a little bit about how exactly do you feel it can be possible. Okay, let's talk about it. Can you give me example of an array, a random array, for which there will be no such triplet? Just imagine what kind of array will have no such triplet I, j, k, for which the relation is true. How about an array which is sorted in descending order? Imagine an array sorted in descending order. Will you ever have such a triplet? So let me write it down. Let's say you have 5, 4, 3, 2. This is your array. Do you have any triplet like that? The answer is no. Because if it is sorted in descending order, then for each element, everything in the left will be larger and everything in the right will be smaller. But what you want is something else. You want that for an element, something in the right should be larger and something in the left should be smaller. You get this? Why is it not possible for a descending sorted array? Yes or no? Right? Okay. Now, if you understand it, you can build a very simple approach on top of it. This is nothing special. Very, very simple. Just pure common sense. Tell me one thing. Let's say you have an array like that. And there is an element somewhere. Let's say that element is X. Okay? That element is X. Now, if everything in the left is larger than X, if everything in the left is larger than X or equal to X, then it's good to drop the X. It's good to say that, X can never be my middle element. X can never be my middle element. Now, I would try to tell this in a different manner. Let's say the smallest element in this prefix is known. Let us imagine our X is 10. Our X is 10 and the smallest element in the left part is 15. You know that. If the smallest element in the left part is 15, can it ever happen that 10 is the middle element and 15 is the first element? Is it possible? 15 is the first element or anything from this part is the first element? The answer is, it is not possible, right? That's 15, the maximum element in this part. Okay, the same idea can be given in this direction as well. Let's say you somehow know the maximum in this part. And let's say the maximum in this part is 7. If the maximum in this part is 7, you can say that, hey, the maximum itself is 7, so nothing in this part is going to be greater than 10. Nothing in this part is going to be greater than 10. Now, do you feel that if you somehow track something in prefix and something in suffix, then for each element you can decide whether that element can be my middle element or not? Think about it for some time. And if you feel you can track something, also come up with what is it that you will track. Yeah. So just imagine, how about tracking something called as prefix max? If you know the prefix max, will it help you? Or probably change it to something like prefix min. If you know prefix min, then will it help you? Prefix min tells you the minimum in this part. If the minimum in this part is smaller than 10, then you are sure that there is at least one element which is smaller than 10 towards its left. Similarly, if you know about suffix max, which means maximum in the right side, if suffix max is greater than 10, it means there is at least one element which is greater than 10, right? Now, once we have this knowledge, then our job is very easy. So imagine you have computed prefix max ending at each index, and you have also computed suffix max starting from each index. So prefix min ending at each index and suffix max starting from each index. So if you have that idea, do you feel you can solve this question? Yes, because now at each index of the array, let's say you are traversing this array from beginning till the end, at each index I, you can look at what was the minimum element from 0 to I minus 1. The minimum element from 0 to I minus 1 will be present in some array called as prefix min, which you have pre-computed. This tells you what is the smallest element from 0 to I minus 1. And then in order to know what is the maximum from I plus 1 to the end, you can look at your suffix max. So suffix max of I plus 1 tells you what is the maximum towards the right side. And let's say this value is A, this value is B, then your job is done. Then you can just check whether your current element is greater than A and the current element is smaller than B. So you can put this check for all the elements. You do not need to start from 0 because the first element can never be middle element, and you do not need to end at n minus 1. You can end at n minus 2 because the last element can also never be the middle element. And for each element in this sandwich part, which is from 1 to n minus 2, you can put these checks. If for any element you see that A is smaller and B is larger, you can just return true and the job is done. So how much time did you take to solve this question? You just took order n time, because in order n time, you can pre-compute both these things, and in further order n time, you can write your logic, get your job done, which is way better than n cube. This was just a very simple example where we kind of realize how using a simple idea of pre-computation, we can optimize, rather I would say, we can optimize many questions that are related to arrays. Yeah? Okay. If you have anything to ask, you can. Then we will learn about one more technique, and then that should be it for today. So let's talk about another technique. So it's a question rather. There is a concept of something called as majority element. What is the meaning of majority element? So let's say you have an array that contains 1, 2, 1, 1, 2. Here the majority element is 1. Why 1 is majority element? Because 1 appears more than n by 2 times. So what is n? How many elements are there? 5 elements are there. What is 5 by 2? 5 by 2 is 2. The floor is 2. Now when you look at 1, the frequency of 1, or in other words, the number of times 1 appears is 3, which is definitely more than 2, right? So here I would say 1 is my majority element. The question is very simple. You will be given an array and you will have to return the majority element present in that array. Now, don't you think that it might happen that the array does not have majority element. At times it can happen. So let's say you have an array that contains 1, 2, 3, 4. What is majority here? Nothing. Because number of elements is 4 and there is no element which is appearing 4 by 2 times, there is no element which is appearing 2 times. So there is no majority element here. The question is that if you have a majority element, you return it. If you do not have it, return -1 or return null. So that's what the question is. Does it make sense to everyone? What is it that we are trying to solve? So what can be the simplest way to solve this question? The simplest way can be you find the frequency of all the elements and get your job done. So finding frequency, in order to find frequency, you can use different things. You can use a hash map if you know about hashing, or you can use a frequency array. So let's say you build a frequency array where you are tracking frequency. I won't go into those details of using frequency array or hash map because that itself will take a lot of time. I'll talk about yet another simpler approach. Another simpler approach can be if you want to know how many times an element is appearing, you can probably sort the array. Because if you sort the array, identical elements will be bunched together. So if you sort this thing, what will you get? You will get 1, 1, 1, 2, 2. Now starting from here, you can track how many 1s are there. Starting from here, you can track how many 2s are there. Or for that matter, for each element, you can track how many of that element is there. So you know the count of that element, and then you can just check that count. If that count is greater than floor of n by 2, then your answer will be true. Otherwise, your answer will be not true. I mean, you would say that that particular element is our majority element. Okay, one more common sense question. Can it happen that in an array, you have got more than one majority element? Is it possible? The answer is no. Because if the size of array is n, let's say the size of array is 10, then if you say that there are two majority elements, x and y, then you are saying that x appears for more than 5 times and y also appears for more than 5 times. How is it possible given that the size itself is 10? Because x plus y will be a value which will be greater than 10 if both are independently greater than 5. So it is guaranteed that there will be only one majority element, but certain times in arrays like this, it may not be there. Okay, these are just precursors to an algorithm which we are going to learn, but does it all make sense, these common sense things? Okay, so now we will utilize the fact that there can be only one majority element. Okay, so let's look at the board. Also, I would tell you the approaches that we have discussed using hash map. If you use hash map, you will use some extra memory. If you sort, you will use some extra time and log n. So the attempt is to solve this question in linear time, which is order n, without using extra memory. How to do that? So let's say you have some elements like 1, 1, 1, 2, and 2. So there is an approach of voting. Let's say you vote for an element, you vote that, you know, this is our majority. So maybe what we can do is, we can say that, you know, the first element, let us assume the first element is our majority element. What is the first element? 1. The first element is 1. And because you have seen it, so you can give it a vote. So see, this is your element, and this is the vote. Votes given to that element. Now what do? You move on to the next element. If the next element is same as that element, you increase your vote. So you will increase your vote and it becomes 2. Now move to the next element. Again, it is same as the previous element. Increase your vote. 3. Right? Now move on to the next element. If the next element is not same as the previous element, which is the case here, this is 1, that is 2, decrease your vote. And now again come here, you again see that this element is not same as the previous element, decrease your vote. What has happened here is that the vote has remained positive. The vote has not become zero, or this vote has not turned negative. It is continuing to be positive. If you think why, the answer is very simple. Because this thing is appearing for more than n by 2 times. So no matter how many extra other elements are there, they'll not be able to completely cancel it. So if let's say the frequency of majority element is 6 in an array of size 10, the remaining elements will not be able to cancel it together. Even together, they'll not be able to cancel. That's the idea. Now, you may be wondering that, hey, how will this approach work if these elements are jumbled up and things like those? What to do in such scenarios? So I would say, no need to worry. Even in that case, this approach is going to work. So let's say I jumble up the elements a bit, and now you have 1, 2, 2, 1, 1. Can I still say 1 is majority element here? Yes. See, this idea is based on the fact that you track an element to be your potential majority element, and you also track its vote. Now, every time when you see the same element as your candidate, you give a +1 vote. Otherwise, you give a -1 vote. Certain times what can happen is that the vote might become 0. If the vote becomes 0, then you can let go of that candidate. Why? Just think of it like that. You do not know what are the remaining elements. If I hide them, then you just have 1 and 2. So let's say you start from here and you say that, my current majority element is 1 and the vote that I have given is 1. Now, when you move ahead to the next element, what will you do? You will see that this is 2, which is different from 1. Because it is different from 1, you will reduce the vote, and now vote becomes 0. Because vote becomes 0, that means number of 1s is equal to number of 2s. So you can't trust the fact that 1 is majority. So let go of 1 and now introduce a new candidate, probably this 2 itself. So now you can say that, I have 2 with me and I have seen it once. So 2 could be my majority element. And now you can move on to the next element, which is 2. And again, it is same as that. So you can vote it again. Yeah, looks very promising. Looks like this 2 itself is going to be our majority element over here, right? Now what will happen? You'll move on. You'll move on at this place and you will see that this is 1 and this 1 is not same as that. So you will again reduce the vote. Now again you will see 1 and you will see that 1 is not same as 2. So you will again reduce the vote. The moment you reduce the vote, what will happen? It becomes 0. The moment it becomes 0, you will say that, hey, 2 no longer can be our majority element because I have seen so many 1s or so many other elements. So what you will do? You will change your majority element and you will say that now its vote is 1. So basically what you do, whenever you see the same element as your current candidate, you increase the vote. Otherwise, you decrease the vote. Now, when you decrease the vote, at times your vote can become 0. When it becomes 0, then the current element should be taken as the potential element. So at the end of the algorithm, whatever is your element, that can be your majority element. Why I'm saying can? Because in cases like this, you may not have any majority element. So whatever you have, you can check frequency of that again. You can just count how many 1s are there. If that count is greater than n by 2, you can say that itself is majority element. Nothing else is majority element. And at times it can happen that whatever that element is, that does not have a count of greater than n by 2. So in that case, you can conclude there are no majority elements whatsoever. So this is the basic idea behind all of this. You can jumble up these elements in any manner, and you will see that eventually you will get 1 itself as the majority element. See, even if you have additional elements, extra elements, then also this approach is going to work. No issues. Try putting 4 over here. Still your approach will work. What's the big deal? Because you can realize that by the time you will come here, you will say that your current majority element is 4 and the vote given to it is 1. Because I have seen 1 instance of 4. Now, the moment you come here, what will happen? You will say that this is 1 and that is 4. Different. So reduce the vote count. And the moment vote becomes 0 for 4, then you will kick this 4 out and you will say that now maybe I should rely on this guy. And I have seen it once so far. And now you move again, you see 1. So by the end of your algorithm, whatever element is that will be declared as your majority element, but you'll have to check for its frequency at the final stage to just conclude whether it has a frequency of greater than n by 2 or not. Because if you run your algorithm in something like this, by the time your algorithm terminates, you will see that 4 is your majority candidate, but when you find its frequency, it will not be greater than n by 2. So in that case, you can say there are no majority elements whatsoever. So just to reiterate and conclude the idea, you have two variables. You can try writing the code on your own. You have two variables. The first variable can be initialized to array of 0, which denotes our current candidate for majority. Second variable is to track the count of votes. So you can initialize it to 1 because you have seen it once. So you're giving it a vote of 1 unit. Now you can write a for loop from the next index, which is index number 1 till n minus 1. And every time you compare current element with your candidate. If they match, you increase the vote. As simple as that. But if they do not match, you decrease the vote. When you decrease the vote, check if it has become 0. If it has become 0, that means the previous candidate is useless, kick it out. The new candidate will be current element and give it a vote of 1. Continue this process. By the time you have reached the end of the array, whatever element survived, that will be your majority element, because it is that element whose frequencies cannot be neglected completely by the other elements, because it has a frequency greater than half. Okay, cool. That will be it. We can just keep this much for today. You guys can think more about the concepts that we learned today. You can attempt some questions from internet based on these concepts of, by the way, this algorithm is also called as voting algorithm, Moore's voting algorithm. And the first thing that we learned is called as pre-computation techniques. Okay, cool.
थैंक यू विवेक सर फॉर द सेशन। क्विज का लिंक लाइव डिस्क्रिप्शन में होगा। 30 मिनट तक खुला रहेगा क्विज लिंक। ओके, थैंक यू गाइस।